Lesson 1 is the boring lesson, the ground school if you will, but it is also one of the most important lessons, for without this knowledge, your adventures in the air may come to a crashing halt, figuratively as well as literally. All media must include the following disclaimer. The flight simulator at the Robert Morgade Library Idea Lab is for entertainment purposes only. No part of any lessons, advice, or support may be used toward real-world pilot training. That is our official word. You must understand that these lessons are for entertainment and STEAM educational purposes only. They are not to be applied to any real-world aviation activities. Video learning will not replace the in-house lessons. They are designed to augment them and prepare you, the student, for them. A lot of the lessons can be covered by video, which will allow more hands-on time for you and the instructor. There is a lot of information here. I recommend you view and review this lesson several times, especially if your first in-house lesson is still several weeks away. X-Plane 11 Professional is claimed to be the world's most comprehensive and powerful flight simulator for personal computers, and it claims to offer the most realistic flight model available. X-Plane is not a game, but an engineering tool that can be used to predict the flying qualities of fixed and rotary wing aircraft with incredible accuracy. The software is programmed to launch as soon as the computer is turned on. If the software is not running, simply go to the Start menu, select the Power option, and choose Restart. Rebooting the PC will give you a clean start, enabling X-Plane to run with maximum performance. It will take a while to load, so be patient. While the computer reboots, let's look at the hardware. There are 4 monitors and a set of aircraft controls in front of you. The 3 monitors directly in front are your simulator views, set to give a panoramic view from within the aircraft cockpit. The 4th, smaller monitor is a utility monitor used for instructor operations or displaying a navigation map. We will use this in the advanced lessons. For now, you may ignore it. The aircraft controls are designed to simulate the actual cockpit. If you look at it now, some of what you see you will learn about later in the lesson. Please handle the equipment gently. Do not grasp the yoke tightly with both hands. It is not designed for rough handling. The simple fact is, if you handle a real aircraft roughly, that aircraft may go out of control and put you and your passengers in a dangerous situation. Practice good habits and handle the controls gently. There is a lot of detail covered in this video. This is important to learn so you can successfully operate the software before you learn how to operate the airplane. The Start menu will appear when the simulator is ready for use. This option allows you to set up your own situation, allowing you to choose aircraft, location, weather, and date or time. You may save several situations. This option allows you to load any situation you may have saved, including a flight in progress. This option brings up a few basic instructional interactive flights. Good for familiarization, but they lack in-depth instruction. This option sets the simulator's configuration. Please do not make any changes. If someone does make a change, simply rebooting the PC will reset the default configuration. Now let's proceed. Select New Flight. This new menu has 4 sections. The large box on the left is the aircraft section. The 3 smaller boxes on the right, from top to bottom, are location, weather, and time of day. Let's look at the aircraft section of the menu. The top of this section allows you to choose what AI, or artificial intelligence, aircraft will be flying in your area. You may add or remove aircraft types here. This is good to know, but you don't need to do anything with this now. This section allows you to search for specific aircraft, filtering by class, engine type, aircraft manufacturer, and/or developer studio. This comes in very handy if you have added hundreds of aircraft to your hangar. X-Plane installs aircraft from older versions which are not optimized for use with X-Plane 11, but are still some favorites, so they allow you to choose these by putting a check in the box for Show Extra Aircraft from Old Versions. The aircraft tiles represent the aircraft installed on this copy of X-Plane. They are divided by type: airliner, general aviation, helicopter, etc. By clicking on the hollow star of that aircraft, it will set it as a favorite, and will then put that aircraft in your favorites section on the top to make it easier to find. The default Cessna 172 with the Idealab Skyward paint scheme will be in the favorites section on top of the aircraft list. Select this and its icon will turn blue. A Customize option will appear. Choose the Cessna Skyhawk. Select Customize. This enables options to set with the aircraft. On the line with the aircraft title is a drop-down box. This allows you to choose any of the provided paint schemes for that aircraft. You may also see them by rolling your mouse wheel. The lower left of the aircraft box has two options: weight, balance, and fuel, as well as failures. Select weight, balance, and fuel. The fuel option is important. As the plane flies, it consumes fuel. This fuel level will remain with this aircraft. It is possible that you may choose an aircraft without fuel, so be sure to check this before you begin. Use the total internal fuel weight to increase the fuel amount, being careful not to overweigh the aircraft. You will see that in the round total weight indicator. This will also tell you how much time you can fly if normal cruise practices are used. Select Done when you have enough fuel. Failures. You will want to leave this alone. Play with it when you have become more experienced. Start with engines running. This option is useful when you're just learning and have not gotten to the startup lesson, or if you are beginning your flight in the air. Location. This box allows you to customize your start location. Airports have identifier codes. Stewart Switham Airfield code is KSUA. Airports in the continental US begin with the letter K. Smaller airfields may have other codes like FL45. Alaska and Hawaii begin with the letter P. To find an airfield, either enter its code in the search box if you know it, or open the drop-down menu. Select the filter that helps you find the airfield: city, state, or any other filter. If an airfield will be used regularly, like KSUA, clicking on the hollow star in front of the name will assign it to the favorites filter, making it much easier to find in the future. KSUA should already be a favorite. Select Customize. This opens a new window like the Aircraft Customize option. This enables you to select a starting position for your aircraft, including parking positions, on a runway, or even in flight on an approach to a specific runway. You can choose these options either by selecting them in the drop-down box to the left or by selecting on the corresponding circle on the map. To select a runway approach, you will need to select a runway option in the Starts window, then 3 nautical mile or 10 nautical mile approaches. If you choose this option, be sure to have Start with Engines Running selected in the Aircraft Customization option. Now you can select Confirm when you are satisfied. Weather. Weather configuration can become quite complex. To make it easy, move the slider on the bottom of the window to select a preset option. For beginners, select it to the left for clear weather. Time of day. Time of day offers a slider for quickly changing the time of your flight. If you wish to perform a night flight, it can easily be selected here. You are now ready to fly. Select Start New Flight or Apply Changes if you made changes to an existing flight. Now let's go over the in-flight menu. Sometimes you may want to change your flight parameters or start a new flight while the previous flight is still active. To access the menu while inside the aircraft, bring the mouse to the top of the center monitor. A menu will appear with the following text and graphic icon choices. The text options are to the left, and they are File. The File menu opens options for saving or loading situations, taking screenshots, opening logbooks, or checklists. Flight. The Flight menu offers options to change variations of the simulator and to show optional windows like a map. View. The View menu gives options for viewing your flight, including the popular external views and flight models. Developer. These are developer-related menus. The only option here you may need would be to reload the aircraft if something looked or acted wrong. Otherwise, nothing here is used during these lessons. Plugins. This menu controls additional software added to enhance the program. Again, nothing needed from this menu. Now the icons on the right side of the menu. Pause. This pauses flight in the simulator. Pressing the P key will do the same thing. Flight configuration. Same as the option from the File menu. ATC window. This brings up the air traffic control window. This will be covered in advanced lessons. Map. This brings up a map window. Settings. This brings up the system settings. Again, these are not used within the lessons. Help. This will send you to a help webpage. Now let's go over the different views. Internal views. You will want to fly the airplane from within inside the cockpit with a view over the dash or glare shield. The panoramic layout of the three monitors gives you enough peripheral vision to perform most tasks without changing your view. In case you need to, use the thumb knob on top of the left handle of the yoke to move your view around. Holding the right mouse button down while moving the mouse will also change your view. Press the white index finger trigger button on the left yoke handle or the W key on the keyboard to reset your view to normal. If you have trouble with the thumbstick, use Q to look left and E to look right. F will look down while R will look up. The period zooms in while the comma zooms out. External view. Pressing Shift and the number 4 gives a good external view. Holding the right mouse button down while moving the mouse will also change your view. Shift 5 gives a view from the nearest control tower. Other Shift and number key combinations give a variety of external views, but remember to press W to return inside the airplane. An airplane is a specific type of aircraft that has fixed wings, is heavier than air, and is capable of sustained, powered, and controlled flight. An aircraft is any machine that can fly, like a helicopter, blimp, witch's broom, or hot air balloon. Airplanes come in several classifications. Airliners, business, military, and general aviation are the most common. This is a Cessna 172 Skyhawk, the most popular general aviation airplane ever manufactured, with over 44,000 produced. The main body of the airplane, which holds passengers, crew, and cargo, is called the fuselage. In some cases, the engine will be mounted in the front, in the back, or on top. Many multi-engine jet airplanes have them mounted on the sides of the fuselage. There are also models with one in front and one in back, called pusher-pullers. The fixed wing is the primary source of lift. Some airplanes have them on the bottom of the fuselage, some on the top, while others have two or more. An airfoil is the shape of the wing. Most wings are cambered on top, meaning outwardly curved, or convex, and relatively flat on the bottom. In many multi-engine airplanes, the engines will be mounted in the wings. The wings have control surfaces, which we will cover shortly. Empennage. The rear of the airplane is called the empennage, or tail section. This section holds the stabilizers of the airplane, keeping the airplane under control. Horizontal stabilizers keep the airplane's nose level and prevents it from bobbing up and down. The vertical stabilizer keeps the airplane's nose pointing forward and prevents it from swaying side to side. Both have control surfaces, which will be covered later. Most airplanes rely on wheels to land. Some use skis or floats. There are two main types of landing gear configurations: tricycle and conventional, or otherwise known as tail draggers. Tricycle has 3 wheels, 2 under the wing and 1 under the nose, which is also used for steering. Tail draggers have 2 to 3 wheels. two under the wings, and a wheel or a skid under the tail. Visibility is key. All aircraft have a series of lights to help identify them from afar. Colors will enable other pilots to see which way the airplane is heading. This is the physics behind flight. There are four forces. All four forces must be in play for the airplane to fly. The four forces are: lift, the force that pushes the airplane up into the air; weight, the force that comes from gravity which counters lift, pulling the airplane back to Earth; thrust, the force that propels the airplane forward, allowing the wings to create the lift; drag, the force caused by friction of the air hitting the airplane, slowing the airplane down or limiting its forward speed capability. In fluid dynamics, Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in static pressure or a decrease in the fluid's potential energy. This means that a fluid element passing through a small opening or over a curved surface will travel faster and at lower pressure than the element outside of the restriction. Example: water in the top of a funnel moves slowly, while the water traveling through the tube portion travels much faster with much less pressure. Therefore, the air traveling over the wing, because it has farther to go, travels faster than the air under the wing, producing a lower pressure on the top of the wing. The opposite is the higher pressure under the wing. The result? An object, in this case the wing, will always travel in the direction of the most applied pressure, or up. One of Newton's laws of motion is his third law, where for every action there is an equal and opposite reaction. Air striking the underside of the wing at an angle will deflect off the wing and go downward. The force of this impact will also force the wing upward. The higher the angle in which the air strikes the wing, the greater the force applied to the wing. This is called the angle of attack. One of the most important and commonly ignored aspects of aviation and flight physics is the angle of attack. It is simple to understand if it is explained properly, so I'm going to try to explain it here. This is our airfoil. A wing chord is an imaginary line that travels from the very front of the wing's leading edge to the tip of the wing's trailing edge. Relative air is the direction the wing is traveling into the air, regardless of which angle it is currently at. Angle of attack, or AOA, is the angle of the relative air compared to the wing chord. The higher the angle of attack, the more lift and drag is produced. Too much angle of attack and the wing will stall. A stall in aviation does not imply that the engine quit running like it does in a motor vehicle. An engineless glider can still stall. Stalls occur when the angle of attack is too high and the air traveling over the wing becomes disconnected, in a sense, and can no longer follow the air under the wing. It begins to bubble up into turbulence and the wing loses its lift properties. Control surfaces are parts of the outside of the aircraft that will alter the aircraft's relationship with the air around it. An example I can use is if you have ever stuck your hand out a moving car window, which I highly discourage because doing it is dangerous. But if you have and your palm was flat, it would simply glide along the air. But if you tilted your hand down, the air pressure now on top of your hand would force your hand down. You have just altered the condition that your hand and the moving air shared. These conditions between the aircraft and the air are controlled through control surfaces. Let's look at what they are on the airplane. Ailerons are used to turn the airplane. They are located on the outside of the wings and work opposite of each other. When the yoke is turned to the right, the aileron on the right wing deflects upward, and the aileron on the left wing deflects downward. This action rolls the airplane into a bank or an attitude not level with the ground. The elevator is located on the horizontal stabilizer in the tail section and controls the airplane's pitch, or the nose angle. Pulling back on the yoke will deflect the elevator up, pushing the tail down, causing the nose to pitch up. Pushing forward has the opposite effect. The rudder is located on the back of the vertical stabilizer. Pushing the pedals to the right will deflect the rudder to the right, pushing the tail left, causing the nose to yaw or point to the right. Pushing left has the same effect, but to the left. The flaps are control surfaces on the inboard part of the wing's trailing edge and work together to increase lift by changing the angle of attack. Lowering flaps causes the wing chord to angle higher without the aircraft's pitch changing. You'll see a good description of this later. Trim tabs are small control surfaces to help the pilot hold a particular pitch angle, relieving the pressure needed on the yoke. It works kind of like a cruise control for an airplane. Now let's go inside the airplane. All of these control surfaces you just learned about need to be, well, controlled. And we control them through the use of controllers. In the case of this airplane, we will use a yoke, rudder pedals, flap switch, and trim wheel as our primary controllers. The yoke controls both ailerons by turning it side to side and the elevator by pushing it forward and pulling back. I cannot stress enough how important it is to handle the yoke gently. Fast, abrupt movements can cause your aircraft to depart controlled flight and cause damage to the expensive hardware. It's human nature when something goes wrong, you want to make drastic adjustments to compensate for the problem, but in reality, you're just making the situation worse. For example, if the nose of the airplane drops, the reaction is to yank the yoke back really hard. The result was mentioned earlier. The airplane can depart controlled flight. It takes practice and training to learn to overcome this urge. Crashing the airplane means you must start over. Breaking the equipment means you can no longer use the simulator until we can get the part replaced. Please be gentle. Rudder pedals control the rudder, a control surface used to keep the airplane in a coordinated, comfortable turn. Using slight pressure in the direction of your turn will help the airplane turn properly, relieving any centrifugal forces you would experience in a real airplane. While taxiing on the ground, the rudder pedals are used for steering in most aircraft. Push the rudder pedals in the direction you want to steer, but do it slowly and gently to avoid a ground loop or spinning in circles on the ground. The tops of the rudder pedals will push forward individually, applying brake pressure to that pedal's respective wheel. The left pedal controls the left brake and the right pedal controls the right brake. Apply equal pressure to both brakes to prevent ground looping and to come to a straight, complete stop. The flap lever controls the flap position. Most airplanes have a set of positions. In other words, 10 degrees, 20 degrees, takeoff, fold, etc. Some allow you to set them wherever the handle stops. It is important to keep an eye on this, as the faster you go with the flaps down, the more damage you will cause to the flaps. Controlling the trim tab is done by rolling the trim wheel forward for nose down trim or backward for a nose up trim. I'll explain how this affects your speed in another lesson. For now, just know that if your plane tends to go nose up or nose down without you moving the yoke, your trim is probably not set correctly. For level flight, it should be in this area. Instruments tell a pilot exactly what an aircraft is doing. It tells the pilot how fast it is going, how high up in the air it is flying, or which direction it is facing, and more. The six-pack is a group of 6 of the more important instruments that need regular monitoring. In most aircraft, they are organized in a way that they can be easily and quickly scanned. Airspeed Indicator. This displays indicated airspeed, or how fast the airplane is traveling through the air. This is important because it tells you how fast the air is traveling under your wing. Too fast and the wing may become damaged. Too slow and the wing loses lift, causing the airplane to stop flying. This is different than ground speed. For example, if you are flying at 90 knots in calm air, then you're traveling around 90 knots over the ground. If your airspeed is 90 knots into a 10-knot headwind, then your ground speed will be around 80 knots. If your airspeed is 90 knots with a 10-knot tailwind, then your ground speed is somewhere around 100 knots. Attitude Indicator. This displays the current attitude the airplane holds in relation to the Earth. The top of the indicator in blue represents the sky and the bottom in brown represents the Earth. The orange airplane shape in the center represents your airplane. The indicator lines on the outside of the instrument represent bank angles. The top orange wedges show you which indicator line should be looked at. Keeping the indicator between these wedges will allow you to maintain that bank angle. The top indicator is level flight. The indicators outside to the left or right are 10-degree increments up to 30 degrees, or the safest constant bank you should attempt. Indicator lines past them are for steep turns or advanced flight lessons. The lines in the center represent pitch angles in 5-degree increments. If the dot in the center of the airplane shape is above the solid white horizon line in the blue, then you are pitched up. If it is in the brown below the solid white horizon line, then you are pitched down. It must be noted here that the angle your airplane is pitched does not indicate your direction of flight. In other words, the plane can be pitched 20 degrees up and still be falling out of the sky. This displays how many feet above mean sea level you are. Mean sea level is the level of the oceans. This is very important to remember. If your airplane is sitting on the ramp at Denver International Airport, then your altimeter will read 5,433.8 feet. This instrument is adjusted due to weather. In the US, it is measured in inches of mercury. On a clear day, it will be set to 290.902 inches mercury. As the weather changes, air traffic control will announce a barometric pressure. You adjust your altimeter to match the number, and your altimeter will give you the correct altitude above mean sea level. The turn coordinator and turn and slip indicator, also known as the turn and bank indicator, are essentially two aircraft flight instruments in one device. One indicates the rate of turn or the rate of change in the aircraft's heading. The other part indicates whether the aircraft is in coordinated flight, showing if the airplane is in a slip, meaning the tail leans into the turn because not enough rudder, or a skid, meaning the tail leans out of the turn because of too much rudder. This instrument displays the compass heading that your airplane is facing. On a clear day, it will usually be the direction your airplane is flying. On a windy day, you may need to head into the wind slightly in order to fly to a predetermined location. Example, if your destination is at a bearing or a direction facing away from you of 270 degrees and there is a strong wind blowing from the north, you may have to fly a compass heading of 280 degrees in order to make your plane fly to the destination that is at 270 degrees. The heading indicator has two adjustment knobs. The first is the calibration knob, and it will turn the platter in the heading indicator to match the reading you get off your magnetic compass. Gyro instruments like this one will become slightly off after a period and need to be calibrated before flight. Adjusting this while the engine warms up is all it takes. Match the platter in the heading indicator to the heading displayed on the magnetic compass when the airplane is stationary. The second knob is the heading bug. This is a small orange indicator that will travel the circumference of the platter to point you in a specified heading. If you need to fly to a heading of 110 degrees, turn the knob until the heading bug is over 110. When you fly, you simply keep the bug at the top of the instrument and you will be flying that heading. If your aircraft is equipped with an autopilot, then the heading bug will tell the autopilot which heading you want to fly. This displays your airplane's vertical speed, or how many hundreds of feet per minute your airplane is ascending or descending. This is crucial, especially when approaching to land. Too fast of a descent rate and you will likely damage your undercarriage or landing gear. It can help you determine how your aircraft will react soon. For example, if your vertical speed is 1,500 feet per minute ascending, then your airplane will likely stall shortly. If your vertical speed is 2,500 feet per minute descending, then you will likely overspeed your airplane shortly or operate the airplane faster than it was structurally intended to fly. These instruments provide information on aircraft systems. This displays the engine RPM, or how fast the engine is rotating. Exhaust gas temperature, or EGT gauge. This displays how hot the exhaust is. The hotter the gas, the more efficient the engine. This is used with the mixture knob, which will be explained later. Fuel flow indicator. This indicator displays how many gallons per hour of fuel the engine is consuming. Leaning out the engine at higher altitudes can prevent engine problems and save an extraordinary amount of fuel. For example, if you flew the Cessna 172 from Stewart on full rich, you would run out of gas by Atlanta. If you lean the engine out, you will run out of gas by Chicago. This indicates oil temperature. You must wait until the oil gets hot before flying. Cold oil will restrict an engine's power. If the oil gets too hot, it will start to break down and you'll lose the lubricating properties, which could result in the engine overheating and stopping. That's not a good thing at 7,000 feet. This displays the appropriate amount of oil pressure. An ammeter contains a pointing needle with a value of 0 in the center, positive numbers on the right, and negative numbers on the left. A negative number means more electricity is being used from the battery than is being replaced. A positive number means more electricity is being given to the battery than is being used, or the battery is charging. If you see a negative number, then your battery is not charging. Turn off unnecessary equipment to save battery life, and find a safe place to land and have this repaired. This displays the vacuum pressure which operates several instruments. If this pressure is off, then the instruments it serves may not provide correct information. In most cases, these instruments have the word vacuum printed along the bottom of them. VOR stands for Very High Frequency Omnidirectional Range. This is a short-range radio navigation system for aircraft, enabling aircraft with a receiving unit to determine its position and stay on course by receiving radio signals transmitted by a network of fixed ground radio beacons. We will learn more about this type of navigation in an advanced lesson. The ADF, or Automatic Directional Finder, an NDB, or Non-Directional Beacon, navigation system is one of the oldest air navigation systems still in use today. It works from the simplest radio navigation concept. A ground-based radio transmitter, the NDB, sends an omnidirectional signal to an aircraft loop antenna. The result is a cockpit instrument, or the ADF, displays the aircraft position relative to an NDB station, allowing a pilot to home into a station or track a course from a station. The throttle and mixture knobs control your engine. Throttle manages the fuel amount to the engine. The more fuel, the faster the engine will run. Mixture manages the fuel-air ratio. At full rich, or more fuel and less air, the engine runs powerful at MSL. Remember that? Means sea level? But it is not efficient. Lean means they inject more air using less fuel, but the power drops off. This is good for taxiing. You would use more lean mixture when you get to higher altitudes. Adjust your mixture lean until you get an increase in power and your EGT rises. At full power, pull out the mixture until the EGT peaks, then push it back in 2 notches, or 50 degrees Fahrenheit. That's called lean minus 50. Flap lever raises and lowers the flaps. Note the maximum speed in which flaps can be used. In X-plane, if you're flying too fast for flaps, one flap will fall off and the plane will violently rotate due to the added lift on the opposite side. To counter this, immediately raise the flaps and you may continue to fly. This is a bit unrealistic, but it is designed to remind you that flaps have a limit. Although this is self-explanatory, you may need to be reminded to make sure the parking brake is in the off position prior to landing. Failure to do so will result in excessive tire wear, and if it's on a tail dragger, you will flip over. On the trailing edge of the elevator is a small control surface called the trim tab. I know I mentioned this before, but it is worth repeating. This is used to relieve some of the pressure required to hold the airplane's speed constant through pitch adjustment. When you pitch the nose up to slow down, you would have to pull the yoke back against the air pressure traveling over the elevator. While this is not usually a problem, holding it in that position for an extended period of time is exhausting. To relieve this pressure, a trim tab is installed. After you pitch your nose to the desired angle, you adjust the trim wheel until the pressure on the yoke is relieved. While the simulator cannot simulate this pressure, you will eventually learn to feel the pressure and use the trim properly. Radios are used for verbal communication between pilots and/or air traffic control. They're also used for communications between aircraft and navigational aids on the ground. Other features like ADF and transponder frequencies will be covered later. Autopilot, a system used to control the aircraft by holding altitude, heading, or following navigational aids such as VOR frequencies or GPS locations. You will learn to fly before you take off. Unlike a real airplane, where you will get started on the ground, we start you in the air. The one aspect of flight simulation that cannot easily or economically be replicated is the seat of your pants feel. The sim does not move and therefore does not give you the same sense of gravity or centrifugal forces. In other words, you just sit there. To compensate for this, the sim pilot must pay special attention to those aspects that would otherwise be obvious from the sensations you would experience, like the airplane banking slightly, which would introduce a turn. This is by far the most common mistake a sim pilot makes, not paying attention to the airplane's banking tendencies. So for this reason, your first lesson is to learn how to identify when the plane is banking slightly, why it is doing so, and how to instantly correct it without overcorrecting. It's really simple. You just have to make it second nature, like driving a car inside the lane markers on the highway. After this lesson, your course will continue in a more logical sequence. So let's move on to straight and level flight. Controlling the plane and offsetting left-turning tendencies. A single-engine propeller-driven aircraft will most of the time experience an aerodynamic anomaly called left-turning tendencies. This is more noticeable at slower speeds. There are 4 causes of left-turning tendencies. Prop torque. The torque produced by the propeller spinning is transferred to the airplane. P-factor. When the prop rotates downward, it takes a larger bite of air, causing more thrust on the right side. Gyroscopic precession. This one gives me a headache. The propeller spins like a gyro, and when the tail of the plane goes up, it applies a force to the top of the spinning propeller. That force then transfers its effect at a 90-degree angle from the place of the force, thus producing more thrust on the right side, which is already suffering from the P factor. Does your head hurt now too? Spiraling slipstream. The air being pushed back from the propeller does not go straight back. It is actually swirling around the airplane. When it reaches the tail, it pushes against the vertical stabilizer and adds to the left turning tendencies. Due to these tendencies, your airplane will slightly and slowly roll to the left during flight. Since you cannot feel this roll, you need to be aware of your airplane's attitude and make the frequent but slight adjustment to remain level. It literally is a slight tipping of the wing to the right. This is a very important lesson, and you will need to practice this throughout your entire training so that it will become second nature. Eventually, you won't even think about doing it. Your practice will include monitoring your attitude indicator, your altimeter maintaining 1,500 feet, and your heading indicator maintaining 270 degrees. You will need to fly west, heading 270 for 30 miles. If you do this correctly, you will find yourself on the northernmost tip of Lake Okeechobee. Turn around and fly back to Stewart. This concludes the Lesson 1 video, but I urge you to re-watch this video over and over before your first in-house lesson. I will see you at Lesson 2.